All right, boys and girls, for example 2, you're actually going to refer to this figure on page 285. So if you want to take this and transfer it to an index card, I would. Not so much this one, but mostly this one, okay? So we are going to refer to it a lot. So I would put this in an index card. All right, let's get started. Okay, so we're going to do the checkpoint on page 285, the one that belongs to example 2. And let me just read you what it's asking. It says, given sine of theta is 4 over 5, and tangent of theta is less than 0. They want us to find cosine of theta and tangent of theta. Okay, so here we go. Again, you're going to refer to the book or your index card, okay? So we're looking at the graph and we're going to concentrate to see which quadrant this is going to belong to, okay? So sine of theta is positive, and if tangent of theta is less than 0, that means this is negative. So look for the quadrant where sine is positive. Okay, and if you look, that's either quadrant 1 or quadrant 2. But then tangent has to be less than 0, so then tangent has to be negative. So sine is positive, tangent is negative. And if you look, that belongs to quadrant 2. Okay? So quadrant 2. Okay, why is this important? Well, if you look at quadrant 2, we know that sine is going to be positive, tangent is going to be negative, and cosine will be negative as well. So whatever our answer is has to be negative. Okay? So now you can just refer to your index card here. And we know that sine of theta is y over r. Okay? So this is y over r. And then cosine of theta is x over r. So we have the r part, so we're going to write 5, but this is x, so we're going to figure out x. And then tangent of theta is y over x. Again, it has to be negative. And then we have the y part, which is 4. We have to figure out x, okay? So here we go. Since we're looking for x, we're still going to use the formula that we used earlier. R equals square root of x squared plus y squared. This time what we're going to do is we're going to have to isolate x, okay? So here we go. Same formula, we're just going to isolate x. So we want to get rid of the square root, so we're going to square both sides, okay? And now we're left with r squared equals x squared plus y squared, okay? And then since we want to solve for x squared, we're going to subtract y squared to both sides. So now we're left with r squared minus y squared equals x squared. And then we want to solve for x, so now we want to square root both sides. So now we're left with r squared minus y squared. Okay, so the square root of r squared minus y squared should give us x. Okay, so we're going to use this formula to solve for x. All right, let me just move this. And I'm going to do the work on this side. Okay, so here we go. Our r is 5, so we're going to write 5 squared. Oops, sorry. Our y was 4, so 4 squared. And we want the square root. So this is 25 minus 16. Okay, and 25 minus 16 is 9, but we want to take the square root. And the square root of 9 is 3. So what did we just solve for? We just solved for x. So x equals 3. Okay, so with that said, cosine of theta should be negative 3 over 5. Tangent of theta should be negative 4 over 5. Okay, so it should look like this. And that's it. We're just evaluating trig functions. Okay, so example 1 and example 2 kind of go hand in hand. Okay, I'm just splitting them up so that you can practice. All right, awesome. Let's do one more together. All right, so for this extra example, they actually made it simple for us. So we are given that cosine of theta equals 2 over 3 and tangent of theta is less than 0. So we are going to find cosecant of theta, okay? So let's figure out what we know, okay? So cosine of theta is positive, and of course cosine of theta is x over r. So this is my x, this is my r. And then tangent of theta is less than 0, so this is negative. So now look at your graph and look for the quadrant where cosine is positive. And if you look, that should be in either quadrant 1 or quadrant 4. But now you're going to narrow it down to where tangent is negative. And then tangent's negative at quadrant 4. So we are going to be concentrating on quadrant 4. Okay, why does that matter? It just kind of basically tells you if your trig function is positive or negative, and it helps you evaluate it, okay? So here we go. Now, if you concentrate on cosecant, it's basically the reciprocal of sine. And we don't have sine, okay? But if we're going to be using quadrant 4, sine is negative. And if you do the reciprocal of sine, you should still have a negative. So I'm just going to put the negative there. We know cosecant has to be negative, okay? And of course, cosecant is r over y. And then according to us, to what's given, excuse me, we know that r is 3 and we have to figure out y, okay? So once again, we are going, I'm going to move this up. We're going to use that same equation we did earlier, r equals square root of x squared plus y squared, okay? I'm going to go a little bit faster, but we're going to basically do the same thing we did earlier, except now we're going to solve for y. So ready? I'm going to square both sides, which will give me r squared equals x squared plus y squared. I will subtract x squared from both sides, and that'll give me r squared minus x squared equals y squared. And then I will square root both sides. So that'll give me the square root of r squared minus x squared equals y. Okay? So it's just algebra, okay? Simple algebra. So we're going to use this formula to solve for y. Okay, so let's do that now. So y equals, let me move this, the square root of 3 squared minus 2 squared. 3 squared is 9, 9 minus 4, that gives us 5. So square root of 5, and that's y. Okay? Okay, so basically, I only need to put one value here, and that's square root of 5. Okay, so it would be negative 3 over square root of 5, but we know better. We are going to clean it up. And by now, we should be a little bit faster with our shortcuts, okay? So 3 radical 5 over 5. And then don't forget, it should be negative. So cosecant theta equals negative 3 radical 5 over 5. And that should be our final answer. All right, awesome. Okay, so now let me give you some practice.